The James Webb Space Telescope has observed a galaxy in a particularly young stage of the universe. Looking back in time, it turns out that the light from the galaxy J1120+06 took almost as long to reach Earth as the entire development of the universe up to the present day. Independent measurements show that it is inexplicable how the black hole at its center could have had a mass of more than 1 billion solar masses back then. The findings were published in the journal Nature Astronomy. Recent observations of the material near the black hole were expected to reveal an especially effective feeding mechanism, but they found nothing specific. This result is even more extraordinary. It may mean that astrophysicists understand less about the development of galaxies than they thought. And yet, they are not at all disappointed. The first billion years of cosmic history present a challenge. The oldest known black holes in the centers of galaxies have surprisingly large masses. How did they become so large so quickly? The new observations described here provide strong evidence against some proposed explanations, particularly the ultra-efficient feeding mode for the earliest black holes. Over the universe's 13.8 billion year lifespan, stars and galaxies have changed significantly. Galaxies grew and gained more mass either by consuming gas around them or sometimes by merging with each other. For a long time, astronomers assumed that supermassive black holes at the centers of galaxies would grow slowly along with their host galaxies. However, black hole growth cannot be arbitrarily fast. Matter falling into the black hole forms a rotating, hot, and bright accretion disk. When this occurs around a supermassive black hole, the result is an active galactic nucleus. The brightest of these, known as quasars, are among the brightest astronomical objects in the entire universe. But this brightness limits how much matter can fall into the black hole. The light exerts a pressure that can prevent additional matter from falling in. Thus, over the past 20 years, the observation of very young black holes in distant quasars reaching masses of up to 10 billion solar masses has puzzled astronomers. Light takes time to reach us from a distant object, so looking at distant objects means looking back into the distant past. We see the most distant known quasars as they were less than 1 billion years after the Big Bang, during a period known as the Cosmic Dawn, when the first stars and galaxies were forming. Explaining these massive black holes in the early period poses a significant challenge for current galaxy evolution models. Could it be that the first black holes were much more efficient at accumulating gas compared to their modern counterparts? Or might the presence of dust affect quasar mass estimates in such a way that researchers are overestimating the masses of early black holes? There are currently numerous proposed explanations, but none are widely accepted.